All right, you're going to do activity 2, and it's talking about what are equivalent ratios. They give you 5 to 3 and 10 to 6, and they tell you that those are equivalent ratios. They are. And we know that because to get from 5 to 10, you would multiply by 2. And to get from 3 to 6, you would multiply by 2 as well. When we multiply both the numbers by the same number, meaning 2, it gives us an equivalent ratio. And what that means is, yes, we have more, but it would taste the same, or the color paint mixture would be the same, and things like that. I like to think of like making lemonade. Think of it as 5 cups of lemonade, 3 cups of water, and the lemonade powder, And so if I want to make a double batch, because I'm going to serve it to a group of friends, I would want it to taste the same, which is why I would make an equivalent ratio, just more. So now instead of having just a couple cups of lemonade, I have a pitcher of lemonade. So that's how it works. They want to know if 15 to 12 is equivalent to these ratios. Now, use the original one to help you see if it's equivalent. Go from 5 to 3 always. As well as for B, use 5 to 3 to decide if 30 to 18 is equivalent. And then they want you to give 2 more examples of equivalent ratios that are not shown above from 5 to 3. You get to make them. And then last, I would like you to try to write your own definition of an equivalent ratio. I'll start it. Equivalent ratios are ... Now you try by yourself. All right, welcome back. 15 to 12, I would multiply 5 times 3 to get 15, and I would multiply 3 times 4 to get 12. Are these two the same number that I'm multiplying by? They are not. So that is not equivalent. It would have had to be 15 to 9, or 3 times 4 is 12, so then 20 to 12. You have to multiply both numbers by the same number. Can't multiply one by 3 and one by 4. Either both have to be multiplied by 3 or both have to be multiplied by 4. Moving down here to B, 5 to 30 would be times 6, and 3 to 18 would be times 6. I multiplied both by 6, so yes, this one is equivalent. For C, you could have said many different ones. I just gave a couple to you. I'm going to do by 5 though, so I'm going to do 5 times 5 and 3 times 5, and I would get 25 to 15 as an equivalent ratio. I'm also going to do 6. We already did 6. I'll do 7. 5 times 7, 3 times 7, and I would get 35 to 21. You could have also used any of these two, 15 to 9 or 20 to 12, as equivalent ratios. Moving down to E, equivalent ratios are, this kind of ties in with D, which I did not have you do. It says, how do you know when ratios are equivalent and when they're not? Well, in order to come up with a definition, it's going to tie into letter D. So in order to know if something's equivalent or not, they both have to be multiplied by the same number or divided by the same number. So to make it equivalent ratios, we have to do that. If they're not equivalent, they're not going to be multiplied by the same thing. So I would say equivalent ratios are when both numbers are multiplied and or divided by the same number. You cannot multiply by different numbers. Always has to be the same number.